Hello and welcome to a new episode of creating an underwater survival game like Subnautica. This is part 10, where we will be working on creating an underwater effect for the player as well as animations. First, we're going to resculpt the level. So we're going to create a new scene asset so that we can set up and use a new prefab for our water bodies. And we'll need to set up our water bodies more properly so that underwater effect can be properly implemented. First, let's start by clearing out the extra terrain files in asset/terrain that are not used in the sample scene. Next up, we're going to create a fresh new scene in order to implement the underwater effect. Then, let's create a new water prefab. Let's create a plane by going to Game Object, 3D Objects, Plane. On this plane, we will assign the two water materials we got from the Aquos Light package onto the plane's mesh renderer. Then we'll remove the default mesh collider component and create a box collider for it, and put it under the water layer so that it works with our pre-existing control stream. And set its size attribute to 10 by 10 by 10 so that it covers the entire plane. Then set the center to 0, -5, 0 so that the top face of the collider coincides with the water surface, and set the box collider to isTrigger. So as you can see, the box collider scales along with the plane. We can now scale the plane to be any size we want. Lastly, we'll rename the game object, the plane that we just made, to water body, and then we'll turn it into a prefab. Now if we go back to our water prefab, we're going to add a reflection probe component to it, and we're going to set its box size to 200 by 200 by 200 so that it's the same size of the water plane. The reflection probe is so that we can allow the water material to capture reflections from its surroundings. Next up, we're going to create some new terrain for this new scene. I'm just going to speed up the video. If you need help creating terrain, you can refer back to episode 2, where we give a comprehensive tutorial on how to create terrain. One more thing, don't forget to take your new terrain object, and put it in a folder called Terrains. This way we can keep the project organization neat. Now we need to transfer all of the essentials to the new scene. So we'll need to turn the player and the game manager from the sample scene into prefabs so that we can transfer them to the new scene. So let's start with setting up the player. In the new scene, don't forget to delete the main camera. Now if we go back to the sample scene, we can make the game manager a new prefab and also transfer it to the new scene. Once they are transferred over to our new scene, we will have to reassign some variables to get them working again. In the time manager, we will have to drag in the directional light. And then in the player stat component, we will have to assign the stat bars and stat num attributes with the sliders and text components in the canvas under the game manager. So in order to help automate this process, in case we want to create more scenes in the future, we can add a reset function in both scripts so that we can use the component's reset action in the expector to help us automatically fill up the fields. For now, I'll just reassign all of the stats and stat bars in the player stats component, but then we can open up the script and start creating a reset function. So here in the player stat script, we will be creating a reset function. So yeah, this function is automatically called by Unity. So here, right before I wait, I'm going to create a function called reset. Under reset, so since we have a max stats value of 30, 100, and 100, and a max health value of 100, we're just going to automatically set that in the reset function. After that, we're going to do a function that automatically finds a canvas in the scene, and then it gets a list of sliders within that canvas, which sets the stat bars. It also gets the text in that canvas, so it will set the stat nums. So now if we save this function, whenever Unity editor calls reset on the player stat script, it will actually automatically set the max stats, the max health, the current health, as well as the stat bars and the stat nums. Next up, I'm also going to create a reset function for our time manager script. So same thing as just now, I'll create the reset function. Then in the reset function, we'll look for the directional light object in the scene and set it. So first we find all of the light objects in the scene. Then we'll check through each light to find if it's a directional light. This works because there's usually only one directional light in any scene at a time. So you'll only be finding one. Don't forget to break the for each loop so that we can save a bit of computational power. With that, whenever you create a new game manager, the time manager values will also be properly reset. Next, we're going to start actually creating the underwater camera effects. So the first thing I'm going to do is I'm going to go over to Scripts, Effects, and then I'm going to create a image effect shader. So I'm going to go to Create, Shaders, Image Effect Shader. I'm going to name this the camera underwater effect. So what we're going to do is we're going to create a shader, add on the code, and then apply it to the camera. So how the shader works is basically it will sample each pixel on the camera and then modify the pixel based on the information about the pixel. So it'll look at all the pixels from the camera, it'll see how far away or close it is to the player. Then it will maybe change how it looks based on that information. Like for example, further away pixels will make them more blue, and closer pixels they'll be more less blue and more transparent, and things like that. So how we're going to do this is first we're going to open up the shader. So first of all, in properties, we're just going to make all of the properties hidden in inspector. We're also going to add a property for depth start, depth end, and depth color. So these properties are what we're going to use to help the shader know what to do when to know what kind of information to look for when scanning the pixels on the camera, and also what to do with that information and for each pixel. Then over in Subshader, we're just going to put in some comments. So here I'm just writing some comments on what we're actually doing here. So we're culling off Z-right of Z test always. Next, we're going to go to Pass, and over here, I'm going to set the variables. Next up, I'm going to struct v2f, and here we're going to add another variable, which will be the screen position. So here we add an extra screen position attribute to vertex data, and we're computing the screen position of each vertex in the vert function below. So I'm going to make a comment. So here in the vert function, we're going to set the attribute that we're going to compute the attribute of screen pause. So now the next thing we're going to do is work on the frag function. So I'm going to make a note over here. The frag function is actually run on every pixel that is seen by the camera. So this is where we will be applying all of the post-processing effects onto each pixel. So onto the image that the camera receives, this is where we'll be putting in the logic for the post-processing effects. So here I'm going to take the default logic and delete it. And instead, we're going to do some different logic here. So basically what we're doing is we're going to sample the pixel in i.screenPause from the camera depth texture. Then we're going to convert it to linear depth. And that value is going to be clamped between 0 and 1. Next, we're going to clip the depth between 0 and 1 again, where 1 is if the pixel is further than depth end, and 0 if the pixel is nearer than depth start. So remember, depth end and depth start are 300 and 1 respectively. So basically, we're just making sure that the depth value is between that 0 and 300 value start and end values. Next up, we're going to scale the intensity of the depth color based on the depth by looping the value between the original pixel color and our color based on the depth value of the pixel. So basically, this is the point where, based on the color of the shader, which we're going to pick as blue, we're going to make the pixel more blue the further away it is, and less blue the closer it is to you. And this will get the effect the underwater effect that we want. So in this code, the most important things that we just completed are the frag functions and the vert function. So remember the vert function, we added in another attribute for the camera to another attribute, which would be the screen position. And then for the frag function, we put in the logic of what we want to happen whenever we apply the shader based on the different attributes. Okay, now we can return to the Unity. So for the next part of the video, we will be applying and testing the shader. So to test this shader out, we will need a script on our main camera that applies the shader effects on render image. So we're going to apply the shader effect on the function on render image. So to do that, we're going to create a script called camera underwater effect. So the script is going to have the same name as the shader. Make sure the script has the same name as the shader. So first of all, we're going to need the script to require the camera component. Then we're going to need several variables. We're going to need a public reference to the shader. We're going to have a color variable so that we can decide what color we want the shader to use. Then we'll need a float called depth start. So this will tell us when the water starts. Then we'll need a variable for our camera and then one for a material that that this script is going to create. So we're using this script to create a new material that uses the shader in order to create the effect. So we're just going to set the color to this blue, but you can adjust it in the Unity editor. So the first thing we're going to do in start is to get a reference to the camera that is on the same game object. Then we want to make sure our camera sends the depth information to the shader so that the shader can get how far the pixel is and then compute the logic. Next, we want to create a material using the assigned shader. So we're going to do this in the code, so we don't need to create it in the project window because we're never going to edit this material anyways. So this is just a shorthand statement to create a new material for the shader if the shader doesn't have one. So here we're also going to create a reset function so as to automatically assign the variables that we created earlier, the ones that aren't assigned. So let's write that out. So in this reset function, we're just going to look for shaders in our project folder, and then we'll just return the one that we'll just set our shader variable as the one that has the same name as this script. So we can also delete the update function because we won't be needing it with this script. So what we're doing instead is we're going to be using the onRenderImage function. So this is a Unity function that's called when you render an image, and this is where we need to apply the effect. So here we have to check for the material that we have. We'll see if it's been created or not, and then we can pass on the information to our material. So this material will be using our shader, and it will be looking for the color and then the depth color. We need to set the depth color, depth start, and depth end attributes of the material. Just double check that the shader name attribute names are the same as the ones here. Then we need to apply the attributes to the material using blit. Of course, we need a failsafe if the material does not exist, so we're going to write an else statement. So here we're also just going to use, we're going to apply to image using blit, but we won't be setting the material's attributes because the material doesn't exist. So let's save this script and then go to our Unity. I'm going to apply this script to our main camera. So here it should apply the effect when you click play. Small mistake here. Actually, we need to delete the line sampler2d underscore main text. So for now, we have our shader applied to our players, to the main character of our player, and when we click play, you can see that the entire screen has been rendered as the blue color. So this effect is always on, and we only want it to apply when our camera is submerged in the water. So in order to make sure that the shader is only on when the camera is underwater, we're just going to do a simple physics.overlap sphere in conjunction with the water layer in order to figure out whether the camera is underwater or not. This is because we don't want any colliders on our camera. So if I go back to the camera underwater effects script, here I'm going to add a layer mask, water layers. Then I'm also going to do a header for the variables we use to set the attributes for the text for the shader. Then we'll create a header to notate the variables we used to set the attributes of the shader. Lastly, we'll need a bool in water. Now before our reset function, we're going to use fixUpdate to check if the camera is underwater. Next up, we're going to go down to onRenderImage, and then instead of just if the material exists, we'll check if the material exists and if the camera is underwater. With that, the shader should only render whenever it is underwater. So now we can go to main camera and we can set the water layer to be water. So now if I click play, you can see the shader is no longer rendering, but when I go under the water, you can see the shader is now rendering as blue. Now that we have the basic effect working, we can start fine-tuning it so that it looks more robust. So first of all, the effect renders the same blue color regardless of the environment we're in. In low light areas, we'd rather have the shader be darker and harder to see through. So in order to do that, let's return to the shader. Let's go back to the frag function. If we go down to our look function here, instead of just setting the depth color, we can actually use a mathematical function in order to add this effect. So how we do it is we need to add brackets, then we need to do 0.5 times ambient plus depth color times 0.5. Then we need to take the whole thing multiplied by ambient.w. So what this does is it will blend the ambient color with the depth color that we assign. So the resulting color we get is multiplied by ambient.w, and that will give us the intensity of the light around us. So the deeper you are, the less intense the light is, and it will change the multiplier. So now that we've done ambient lighting, now we want to only apply the effect underwater. If you remember earlier, the effect actually applied for both things above the water and under the water whenever it was applied. Now that we've tackled ambient light, one big issue that our effect currently has is that it also applies to items that are above water. And because the water surface is transparent, we can see through it, and then it causes pixels where it's only the water surface in the sky, which means the pixel is taken to be very far away and completely fogged. In order to fix this, we have to find a way to make the water appear opaque to the camera's depth test from the bottom, so that it doesn't completely fog out when seen. So to do this, I'll return to Unity Editor. And the first thing we're going to do is to create a new layer in our project. So here I've already created it, but we need to create a new layer called Water Surface. Next, I'm going to open up the water body prefab, and I'm going to make a duplicate of the prefab. We'll rename it to Surface. Then I'm going to set the scale of surface to 1, -1, and 1. This actually inverts it as an object. Make sure the position is also set to 0, 0, 0. So here we'll take this surface game object and assign it to the water surface layer instead of the surface. So we can remove everything except for the mesh filter, mesh renderer, and transform. So no more box collider, no more reflection probe. Yeah, and you can keep everything else. Then we need to remove both materials. So I'll remove both materials from element 1 and element 0. Then we'll need to assign Unity's default material. So do note that the surface object is not meant to be seen by the in-game camera, but it does need to be seen by the depth camera. So yeah, it doesn't matter what material is on it, so we're just assigning the default material. So this depth camera I'm talking about is a camera that we're going to be creating in our underwater effects script so that we can detect whenever we're under the surface and block the shader from working on the areas above the surface. So now that we've edited the prefab, you'll see that our water body has the surface game object on it. Now we need to go to our main camera and we'll have to set the culling mask to exclude the water surface layer. So here we'll remove water surface so that it doesn't render it. Next, we'll need to go back to the underwater effects, the camera underwater effects script, so as to create an additional camera that will be looking for the water surface layer. So if I go back to variables, we'll need to create a new variable which is a layer mask. So we're just going to set this mask to be all layers selected by default. The shorthand for this is the squiggly line and then a 0. Next, we'll need another camera variable and we're going to call it depth cam. Lastly, we'll need two new render texture variables, one called depth texture and one called color texture. So here we're going to comment out the line cam.depth texture mode equals depth texture mode.depth because we're going to be changing it. As such, since we don't want the camera to render onto the game screen, we'll have to create render textures for the camera to save the color and depth information to. So here we're creating a temporary depth render texture and temporary color render texture from the depth camera so that we can get a temporary look on how the scene looks like without actually rendering it onto the game scene, onto the game camera. Now we need to create the depth camera. Here we'll be creating depth cam, which will be a game object with a camera script. It will be a child of our main camera game object. Then we need to replicate the settings from our main camera while making sure that this camera can see the water surface layer. We will also change the camera depth texture mode to depth texture mode.depth. So next up, we're going to set the target buffers of our depth cam using the color texture and depth texture render textures that we created earlier. But then we also want to disable the camera because we want to tell it manually when to render and when not to render. Lastly, what we want to do is to make sure to send the depth texture to the shader. So what we've done here is first we created an opaque plane that is invisible to our main camera, and then we created a secondary camera that can detect this opaque plane but does not render pictures to the main camera. So what this does is, what we use that secondary camera for is that with that opaque plane, now we can get more accurate depth readings for the shader to use in order to render the depth of the water accurately. Next up, we need to use the function onApplicationQuit. Here we'll be releasing the temporary render textures of depth texture and color texture. So one more thing we need to do is we need to go down to onRenderImage, and here whenever we render the image we want to actually use depth cam to render. So here is where we will be manually rendering the depth cam. So with that, we need to head back to the shader. So in our shader, we're going to need to add a new property that can receive the depth information from our other camera and apply it. So here, I'll be adding another property. Then after that, we go back to Sampler 2D and we add a depth map. When we go back down to Frag, here instead of using camera depth texture, which was the automatic one that we had before, we'll be using depth map, which will have the accurate depth from our secondary camera. So this is what the shader looks like for now. If you look over here, when we adjust the intensity of the light, you can see that the shader also darkens and lightens accordingly. Okay, now returning back to our Unity, currently we have an issue. Whenever we touch the water, the image effect instantly applies, and this is something that we don't want. So instead, we want the effect to apply gradually as we submerge into the water, filling up from the bottom of the screen. So in order to do that, we have to modify our shader to receive another attribute from our script. So going back to the shader, so here we'll be adding another attribute called water level, and it will be a vector. Then we'll go back down to the frag function. So here in the frag function, we're going to put in a line of code that makes sure that the shader only applies to a certain water level. Then here at the bottom, we'll actually delete this line here and this line as well. And then we're going to do return lurk call, comma, depth color, comma, depth. So now if we go back to our scene, the water level property has an X and a Y value. So the Y value controls how much of the effect has filled up the screen from the bottom, and the X value controls the slant of the effect. So currently the X value will not be used because our camera doesn't roll, so the water level will always fill only vertically. Hence it's possible for us to simplify the if conditional added to frag to if i.screenPause.y is more than waterlevel.y, because we don't have to take into account X. So now that we've set up our shader in order to receive information about the water level and then adjust the shader based on the water level, we can now go back to our script and we have to use the code to determine how much of the camera is submerged at a time and then pass that information over to the shader. So back in camera underwater effect, we'll go back to the fix update. So here, instead of using physics.overlapSphere to check the water and in water, we're going to do it a bit more differently now that we need to know the exact height of the water. So in order to calculate this water height, the first thing we need to do is to get a point of reference in the world. So we're going to get the camera frustum of the near plane. So what that means basically is if we take a look at the main camera, you can see that it's quite a large pyramid shape. What we're going to do, we're going to take a slice out of this pyramid and then get the coordinates from that slice. That's what the frustum is. So when we get those coordinates, we can use them as a frame of reference in order to calculate the water level as compared to our camera. So let's write that down. Next up, we'll check where the water is in comparison to our corners. Since we can't roll, which means rotate along the z-axis, we only need to check how far submerged we are into the water. So corner 1 and corner 0 are the top left and bottom left corners respectively. So we're going to be doing the check using raycast. And from that raycast and the corner can check how far submerged we are into the water. So here we're setting two vector3 components, one for the start position and end position. Next, we're going to do physics.overlapSphere again with regards to the end vector3 we just set. Then we'll check if c.length is more than 0, and if it is, that means we are underwater. So we can set in water to true. And then from here, what I'm going to do is I'm going to do another physics.overlapSphere but this time we'll be checking it in with reference to start, the vector3 we created earlier. So from here we can check if c.length is more than 0 again, and when we do that we can set the vector water level of material to a new vector2. So if c.length is more than 0, that means the player is fully submerged, so we can just set water level to be covering the whole screen. However, if c is not more than 0, then we have to calculate the water level. So here we're going to do a line cast, then we're going to get the interpolation value of the point that the line cast hit, which would be the water layer. So yeah, we need to do the reverse of the lerp function in order to get that delta value. So after that, we'll set the water level of the material. Remember to use 1 minus delta because the line cast is done from the top of the water to the bottom. So we need to get the 1 minus that value in order to get the distance of how far underwater you are. Then over here, we need to do one more else statement. So this is all if the bottom coordinate is underwater, then we'll do all of this. But if the bottom coordinate is not underwater, that means the player is not in water at all. So I'm just going to do an else statement where in water is false. So now that we've done this, the water level should reflect correctly. Oh yeah, one more thing. Over here, you need to add in vector underscore water level. Now, if we go back to our Unity, you'll see that our shader has no errors. So now if we try it out, we should be able to see the effect. So now when we look up, you can see that the shader is only applying to half of the scene. So it's only applying when it above the water, below the water level. So that's everything for the shader. So for the last half of our video, we're going to be adding animations to the main character and fixing a bug with character rotation. As for right now, our character doesn't have any animations. He's forever stuck in this T pose. And if you haven't noticed, the character actually has this rotation bug. So whenever the character looks on the ground, you'll see that the whole body of the character rotates. So this is actually good and fine when we're underwater because we want the whole body to rotate when underwater. But on land, we only want to rotate the camera and the head instead of the whole body. So we'll also be fixing that. So first things first, you need to go to Mixamo and download some appropriate animations for the character. I've decided on 4 different animations. So if we go over to external assets, I'm going to create a new folder called animations. And here I'm going to drag in the 4 animations that we'll need for animating the player character. So the 4 animations are a walking animation, a left strafe animation, an idle animation, and a treading water animation, or any swimming animation that you want. These are the 4 animations that I found on Mixamo. You can go and pick any ones that you want. Just that if they're from different creators, the animations may not match up smoothly. Then we're going to need to set up the rig and animations for these animations that we just installed. So first I'm going to go to the player. So in the main player character, we're going to set a rig. I'm going to choose a humanoid rig and we're going to create it from this model. So yeah, just click apply and you'll create a new rig. So since this is the original model and this is from Mixamo, the rig has already been configured for us, so we don't need to do any editing to the configuring to the rig. But for other models, you'll have to configure the rig properly and make adjustments as needed. Then we can go back to the animations folder and select all of the animations. So we want all of them to also have the same rig, but instead of creating from this model, we'll copy from another avatar and we'll just copy the character rig that we just created. Since these animations were all installed from Mixamo, I was able to Mixamo has the function where you can put in the model and showcase the animation, so we can use the rig from the character with no problem at all. So just click apply and they all will be rigged. Then if we go over to animation tab, you'll want to select them individually. We want to loop all of the animations, but we also want to set all of the root transforms to true. This is just the root transform, rotation, and position is just to make sure that the animation doesn't actually move the model around, because we already have movement handled in programming. So just do that for all of the animations. Next up, I'm going to go back to assets and I'm going to create a folder called animation. So this is where we'll be keeping all of our animation controllers and things like that. Speaking of, I'm going to be creating an animation controller for the player. I'm going to call it Player Animations. Now we can open it up and we're going to start off by creating parameters for the animations. If you don't know, animation controllers have lists of parameters which are influenced by the code, so things like bools and floats, and then based on those bools and floats, it will automatically transition to different animation. So we're going to add two parameters, one called inWater, and make sure it's a bool. Oh, then we're going to add two float parameters, moveX and moveZ. So these will be the different parameters we'll use to change between animation states. Now we can create a new blend tree, and this will make sure that this is our default state. So just make sure that it's set as the layer's default state. I'm going to call this walking blend tree. This blend tree is what we're going to be using to control our animations for idle animations, walking animations, and strafing animations. Then I'm going to create a new state called swimming. Swimming is a lot simpler because there is only one animation for swimming and it doesn't need to change in any way. So then we can connect up these two states. So when we want to go to swimming, we want inWater to be true, and then when we exit out swimming, inWater is false. And then for each of these, it will play the animation on a loop before it goes back. So here we'll set this to the swimming animation. Then we're going to tackle the blend tree. Here in our blend tree, we're going to select it and we're going to set it to 2D freeform directional. So this will take in two different parameters, moveX and moveZ, and based on these parameters, it's going to blend between different animations. How do we do this? We need to set the motions. So here we're going to add a new motion field, and then we're going to set it to walk. So walk will be set at position 0 and position Y as 1. Then we're going to add another motion field, which will allow us to see the graph. So this red dot is a representation of our moveX and moveZ values, and then we'll have different points in the graph for different motions. So that is our walk motion. Next, we're going to do a strafe left animation, and we're going to set this to -1, 0. So when our moveX is set to -1 and our moveZ is 0, then we'll be doing the strafe left animation. And then if we go between these two values, they'll actually blend between the two animations for us automatically. So with that, we're going to set all of the other animations. So here we need to set another strafe left animation, but this time we're setting it to 1 instead of -1, 0. And here we're actually going to mirror the animation. So actually it becomes a right strafe animation because it's mirrored. After that, we're going to add another motion field for walking, and we're going to set it to a Y of -1. Here, because we're going to be walking backwards, I'm actually going to make the animation play in reverse by setting the speed to -1. So here, the walk animation will actually be backwards. Lastly, I'm going to add one more animation, which will be the idle animation. and this will be set right in the center. So between these coordinates, will be the blend tree will be blending between these three animations. So yeah, depending on what our move X and move Z is, the animations will be blended accordingly. So now if we go over to our player prefab, it has already been set as a prefab earlier in this video, we can add in a new component called an animator. So here, animator component. Here we can set the avatar and the controller. So the controller will be the animator controller we just created, and the avatar will of course be the rig that we did just now. So now that we have the animator over here, we're going to need a way for the animator to set these bools and floats. So to do that, we need to go into the player controller. Oh yeah, one more thing. Don't forget to set the animator and apply it to the prefab. So now we can open up our player controller. So in our player controller, I'm going to minimize most of the areas, and instead we're going to go up to our variables. So in our variables, I'm going to add another header right below player movement. So the header is called player animation, and it will just have the variable of the animator. Then if we go down to awake, we can set the player anim by getting the component of the animator. Then I'm going to go over to update functions, and in this region I'm going to create a new function. The function is going to be called update anim, and in this function we'll just set the bools and the floats of the player anim based on the existing bools and floats that we have. So do note, be very careful, make sure you use move Z instead of move Y, because we use move Y to calculate verticality movement when underwater, and move Z is actually our forward and backward movement, which is the one we need for our walking blend tree. So lastly, we just need to go to our update. Right beneath look around, I'm going to put in the update anim function. Now if we go back to our Unity, we can test out these animations. So I'm going to move my game view to the side. We still have the strange rotation, but if we look at our player, he's currently in an idle animation, and when we move to side, we have strafing. And then when we move diagonally, we actually have a very smooth blend of character animations. If we actually go underwater, you can see that the player has swapped to underwater animations. So that's our animations working. Now for the last part of the video, we'll be updating the player rotation. If we recall earlier, the player rotation works well in water, but it actually looks very awkward on land, so we'll be improving it. So what we're going to need to do is we're going to go right back into the player controller script, and then we're going to go find the look around function. So if you go down to movement functions, the look around function is right here. As you can see, this is the line of code that actually sets it such that the entire body rotates from left to right as well as up and down. However, we only want this kind of rotation when we're underwater, and instead we'll have to have a different set of logic for rotation on land. So here's how we're going to do this. First of all, I'm going to use the in-water bool to check if the player is underwater, and if the player is underwater, we'll do this rotation as per normal. Then, we're going to create the logic for when the player is on land. So what we're going to do on land is we're still going to turn the body left and right, but instead of turning the body up and down, we'll be doing the camera itself to be turned up and down. This way, we won't get that weird movement where the entire body tilts towards the floor. So in essence, what we did was we took this line and then we split it into two separate parts, one that controls the left to right rotation and one that controls the up and down rotation. And since we're rotating the camera on land, whenever we go back into water, we actually need to reset the camera transform rotation. So I'm just going to add in a line here to reset the camera. So with that, that's actually everything for our rotation. If we return to our Unity, let's see how it works. So if we look at our player, you can see that the player is still rotating left to right, but the camera rotates up and down. Of course, the camera also clips into the body of the player itself, which is not good, but we can adjust that. Then if we go underwater, you can see here that the camera is no longer rotating independently, but instead the entire body rotates with the camera. So yeah, that's all for the code. One last thing we need to do is to adjust the main camera. So what I'm going to do is I'm going to drag it out a little bit. And then when we click play, we'll just see if it intersects. So no, now we can actually look down at our character's body. And then if we go underwater, let's check if there's any clipping between the model and the camera. No, it doesn't appear so. So yeah, we did it. So yeah, we can just apply this change to the prefab. And don't forget to also apply the camera underwater effect script to the prefab as well, so that the prefab also has it. So that's everything for today's episode. We managed to create a shader with a lot of complexity and depth. We also added animations to the player character, and we also improved the player rotation. So thank you for watching. See you next time. If you want to support our channel, you can help us by becoming a patron, because this will give you access to project files for all of our tutorials, as well as Patreon exclusive posts on the blog. So any support you give will go a really long way. Right now, we're not making as much money back as we are putting into the content creation. So if you donate, we'll be able to make this a long-term and more sustainable endeavor. See you in the next video.